Everyone, I'm Professor Harrison, and welcome back to our module on statistical inference. Today we're going to cover what a confidence interval actually means, and more importantly, what it does not mean. This is one of the most frequently misunderstood ideas in applied statistics. We're following Bess, an investigative journalist on a cold case that she can't let go, and today she's looking at a regulatory case built almost entirely around a fund manager's misstatement of what a confidence interval tells you. A fund manager sent his clients a quarterly letter. In this letter, he reported a 95% confidence interval for the fund's expected annual returns and told clients that they could be 95% sure their returns would fall in that range over the coming year. A regulator flagged it. The fund manager argued the statement was reasonable. Bess is now investigating whether the statement was true or not. Bess pulls up her case file. Let's start with the interval itself. The fund had 64 months of return history. The sample mean monthly return was 1%, and the sample standard deviation was 4%. The standard error then ends up being the 4% divided by the square root of 64, which is exactly 0.5%. Using a t-interval with 63 degrees of freedom, where the 95% critical value rounds to about 2, the interval is going to be 1% plus or minus 2 times 0.5, which is around 1% plus or minus 1%, so the 95% confidence interval for the true mean monthly return runs from 0 up to 2% per month. Now let's go back to what the fund manager said about what the interval means. He said that we are 95% sure that returns will fall between 0% and 2% next year. And that is wrong in a very specific way. Here is the correct interpretation. A 95% confidence interval means if you repeated the sampling and estimation procedure many times, each drawing from a fresh 64-month sample, computing the mean, computing the interval, would end up resulting in about 95% of those intervals containing the true population mean return. The 95% is a property of the procedure, not of this particular interval. So let's make this as concrete as we can. Imagine running this exercise 100 times. Each time we get a fresh 64-month sample from this fund. Each time we'll end up with a sample mean and sample standard error and a confidence interval that we can build from them. We're going to end up with 100 different intervals, all at slightly different locations and slightly different widths. The 95% confidence level is telling you that about 95 of those 100 intervals are going to end up containing the true expected return. 5 of them, however, are going to miss it. Not because anything went wrong, just because sampling has some randomness to it. And 5% of the time, the sample mean ends up far enough from the true value that the interval does not capture it. The interval that Bess is looking at, 0 to 2%, is just one of those intervals. It either contains the true expected return or it does not. We don't know which. The 95% tells us about the population of intervals the procedure is going to generate, not about this specific one. So here is why that distinction matters. The true expected return is a fixed number. It is not something that varies from year to year. It is a property of the fund's return generating process, and it doesn't change just because we look at it. It either falls inside this interval or it doesn't. There is no 95% probability in there. The randomness is in the interval. The interval is random because it was built from a random sample. The parameter itself is not random. One common question is whether we can say anything about probability at all once we build the interval. The answer is yes, but we have to say it with care. Before the data are collected, before the interval ends up being constructed, there is a 95% probability that the interval you're about to build will contain the true value. The probability here is real. It comes from the sampling distribution. Once we actually build the interval, however, the outcome is determined. Either the interval captured the parameter or it didn't. The 95% probability no longer applies to this specific realized interval. Instead, it's something that we can say about the process that generated that interval in the first place. In practice, finance professionals often use a looser framing. So they'll say something along the lines of, the interval gives us a plausible range for the true expected return. This is workable as an intuition as long as you are clear that the plausibility comes from the estimation procedure, not from any claim about what the market will do next year. A confidence interval is also not a prediction interval. These sound similar, but they answer different questions. A confidence interval answers, where is the true long-run mean? A prediction interval answers, where will a single future observation fall? Same general structure, but they have different targets. A prediction interval would be far wider than the confidence interval, because it has to account for both the estimation error and the actual return variability. When a manager says we are 95% sure that returns in the next year are going to be in this range, they are not describing a confidence interval. They are describing what will happen with a single individual observation, which is different from a mean return. In her article, Bess explains this to her readers. The fund manager said that they were 95% sure that the next year's return was going to fall within this interval. However, that's not correct for two reasons. First off, next year's return is but a single observation, not a long run mean. So the uncertainty about that observation is going to be much wider than the mean return that's calculated from the historical sample. The second issue is what the interval is actually saying. It's saying that the estimation procedure that was used to produce this estimate is going to capture the true long run mean around 95% of the time. The 95% is a characteristic of the sampling procedure, not a characteristic about future expectations of a single return. So if clients end up taking this 95% sure at face value, then they're going to be taking on risk that they might not necessarily understand. So that's confidence interval interpretations. A confidence interval is interpreted at the level of the procedure, not at the level of the parameter itself. For example, with a 95% confidence interval, the correct reading is that the methodology that generated that interval is going to contain the true parameter around 95% of the time if we were to take many samples. So make sure to avoid the two most common mistakes when interpreting confidence intervals. The first mistake is treating it as a statement about where a single future observation is going to fall. It's not. It's a statement about the true long-run mean. The second is treating it as a guarantee that the true mean sits inside of the interval. That's also not true either. It is a statement about the procedure that generated the interval, and we run that procedure many times, then about 95% of those intervals you produce are going to contain the true mean. This one might or might not. The confidence is in the method, not in the result itself.